critical angle and total internal reflection. Now, say light is moving from an optically denser medium to optically rarer medium. This is an optically denser medium to optically rarer medium. If the ray of light falls at an angle of incidence I, light bends away from the normal angle of refraction is R. This is the first medium, this is the second medium. So refractive index of second medium with respect to first medium is sin I divided by sin R. Now, if the light falls at an angle known as critical angle, if the light falls at an angle known as critical angle, this is my normal. This angle is called I suffix C, called critical angle. Then light grazes the surface where the angle of refraction becomes 90 degree. So how do we define this critical angle? Critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degree. Now for this case, we can write refractive index of the second medium with respect to the first medium is sin IC by sin 90. Value of sin 90 is 1. So this becomes sin IC by 1. From the principle of reversibility of light, refractive index of 1 with respect to 2 is 1 by 2 with respect to 1. This becomes 1 by sine IC, and this is called cosec IC. So you see, here the critical angle sine IC can be written as 1 by refractive index of 1 with respect to 2. So critical angle IC depends on two factors. Critical angle IC depends on two factors. Number one, it depends on the refractive index. That means refractive index depends on color or wavelength of light. And it depends on temperature also. These two factors affect refractive index, and if they affect refractive index, definitely they are affecting mu. And mu, if they affect mu, then they will affect IC. Now, how does color or wavelength affect the refractive index? Refractive index is speed of light in air by speed of light in medium. Speed of light is maximum for red color. So mu is minimum for red. Mu is minimum for red. So, how does it depend on the color or wavelength? Mu is minimum for red and IC and mu is inverse. So you can say for red, IC for red is more. So, for red color, critical angle is more because red color has minimum refractive index, and for violet it will be the reverse. Now, as temperature increases, let me discuss the effect of temperature over here. As temperature increases, what happens? Refractive index is speed of light in air by speed of light in medium. The density of the medium decreases, so V increases. If V increases, what happens? Mu decreases and critical angle will increase. So as temperature increases, critical angle will increase, because as temperature increases, the medium becomes rarer, speed increases, and as speed increases, mu decreases, and mu and IC are inverse. So as mu decreases, IC increases. So critical angle depends on two factors, color or wavelength and temperature. For color, red color has minimum mu, so critical angle for red is more, for violet is less. And for temperature, as temperature increases, critical angle also increases. Now, if the ray of light falls at an angle greater than the critical angle for the pair of media, This is my normal. This angle I is greater than IC for the pair of media. Then the light no longer suffers refraction, it will suffer reflection. 100% reflection, obeying the laws of reflection, and this phenomenon is called total internal reflection. This phenomenon is called total internal reflection. Now, what are the essential conditions for total internal reflection? What are the essential conditions of total internal reflection? Now, there are two essential conditions for total internal reflection. Number one, light should travel from an optically denser medium to optically rarer medium. And number two, the angle of incidence in the denser medium should be greater than the critical angle for the pair of media. Here the angle of incidence should be greater than the critical angle. So number one, light should be traveling from an optically denser medium to optically rarer medium. And number two, the angle of incidence should be in the denser medium should be greater than the critical angle for that pair of media. So, if the light falls at an angle less than the critical angle, we suffer refraction. Equal to critical angle, it will graze the surface, and more than the critical angle, it will suffer total internal reflection. Some applications of total internal reflection of light. First application, deviation of a ray of light through 90 degree. Now this is done by a 45 degree, 90 degree and 45 degree prism. deviation of a ray through 90 degree. Now let us take a prism which is an isosceles right-angled prism. This angle is 90 degree, this angle is 45, and this angle is 45. A ray of light which comes normally enters normally. A ray of light which comes normally enters normally. Now if we can draw the normal over here perpendicular to the surface, if this is 90 degree, this is 45, then this angle is 45. My angle of incidence here is, this is the normal, so angle of incidence here, I, is 90 degree minus 45, that is 45 degree. Critical angle for glass is 42 degree. So here the angle of incidence is 45, which is greater than critical angle. The angle is greater than critical angle. If the angle is greater than critical angle, what will happen? Light will suffer total internal reflection. So this angle is 45. Angle I equal to angle R. Full angle is 180 degree. This is 180 degree. So this angle is 45. If this is 45, this is 45, then this angle is 90 degree. And if the light falls at an angle of 90 degree, what will happen? It will go out straight. Now, if the prism wouldn't have been there, light would have gone out straight. Due to the presence of the prism, the light suffers a deviation. This is my angle of deviation delta. This is my angle of deviation. Now, if this angle is 45, then this angle is also 45. They are vertically opposite angle. So what is my angle of deviation here? 45 plus 45. 45 degree plus 45 degree. So light is deviated through 90 degree. If you take another ray falling on this prism, it will follow the same path. This angle is 90 degree. This is my normal. This angle is 45. This is 90 degree. It will follow the same path. Now this is used in a periscope. This is used in a periscope. The use of this is a periscope. And this is much more better than the periscope with mirror, because here the reflection is 100% reflection of light. Deviation of a ray of light through 180 degree. Now this is also done with a 45 degree, 90 degree and 45 degree prism. Now see, this is my prism. This is 90 degree. This is 45 degree. And this is also 45 degree. A, B and C. Let a ray of light fall normally at this surface. Now, if it falls normally, it enters normally. This angle is 90 degree. Then this angle is 45. Now, is it my angle of incidence? No, angle of incidence is the angle which the incident ray makes with the normal. So this is my normal and this is my angle of incidence. Now 45 degrees greater than critical angle. Critical angle is 42. So what happens? Light suffers total internal reflection such that angle I is equal to angle R. If this is 45, then this angle is also 45. Now, here this is my normal. If this is 45, this is 90, this angle is 45. If this is 90, this is 45, then this angle is 45. Now this angle is 90 degree. So this is 45. Now since here also the angle of incidence is greater than 42, here also light suffers total internal reflection. So if this is 45, this angle is also 45. Full angle is 180 degree. So this angle is also 45. If this is 45, then this angle is 90 degree. And if it is 90 degree, then light would go out straight. So light was coming like this, and it is totally deviated through 180 degree. Say here we have an object. Here is an object PQ. This is my object. If you take a ray from Q, then a ray of light coming like this will follow the similar nature. It will suffer total internal reflection over here. Again it will suffer total internal reflection over here. So what will happen? This light is coming from Q. It's coming from Q. So this will be the image of Q, Q dash. And this light is coming from P. So this will be the image of P, P dash. This is my image. Now, this is used in the action of prism in a binocular. It is used in a binocular, and at times it is used in camera to invert the image without loss in intensity. Why without loss in intensity? Because total internal reflection is 100% reflection. That's why no intensity is lost. Deviation of a ray through 60 degree, and this is done by an equilateral prism. See, we have an equilateral prism. A ray of light is falling normally at one surface. It is falling normally. Since it falls normally, it goes straight. This angle is 90 degree. If this angle is 90 degree, this is 60, then this angle is 30 degree. Now, is 30 degree my angle of incidence? No. Angle of incidence is the angle which the incident ray makes with the normal. So this is my normal. This angle is 90 degree. If this is 90 degree, my angle of incidence is 60 degree. My critical angle is 42. So 60 degree is greater than 42. So it will suffer total internal reflection. So if this is 60, this is also 60. This angle is 30. This angle is 90 then, because 30, 90, 60. So if it is 90, light goes out straight. Now if the prism wouldn't have been there, light would have gone out straight. Now because of the presence of the prism, light suffers this angle of deviation delta. This is my angle of deviation delta. If this angle is 30 degree, then this angle is also 30 degree. Then angle of deviation is 30 plus 30. Here the angle of deviation is 30 degree plus 30 degree. It is 30 degree plus 30 degree. So my angle of deviation is 60 degree. Here my angle of deviation is 60 degree. Let us take the next example. Number D. Here light suffers no deviation at all. Light suffers no deviation at all. Here again, here we have a prism. This is A, B, and C. This angle is 90 degree. This is 45. This angle is 45. A ray of light falls parallel to AC. Here, this is my normal. This is my angle of incidence. Light bends towards the normal. Here this angle is R. This angle is 90 degree. So this full angle, this full angle is 90 degree plus r. If this angle and this angle and this angle should be 180 degree, so this angle is 180 degree minus 45 plus 90 plus r. This is equal to 45 minus r. So this angle is 45 degree minus r. Here if we draw the normal, this angle becomes, since this is 90 degree, 45 plus r. 45 plus r is greater than 42. It is greater than 42. So light will suffer total internal reflection. It is greater than 42. This angle is greater than 42. So light will suffer total internal reflection. If this angle is 45 plus r, because angle of incidence and reflection are equal, this angle is 45 minus r. So this angle will be 90 plus r. If this angle is 90 plus r, and if we draw the normal at that point, if we can draw the normal at this point, the full angle is 90 plus r. Now this angle is 90 degree. Total angle is 90 plus r. Therefore this small angle should be r. The small angle should be r. Now we know from the principle of reversibility of light that if light falls at an angle I and gets refracted at an angle r, if light comes at an angle r, it will go at an angle I. So here the light is falling at an angle r. This angle is r. This angle is r. So what happens? Since the angle of incidence is r, light will emerge, making an angle I. So light will emerge in this way, making an angle I. It will go parallel to the direction of the incident ray. So there is no deviation at all. There is no deviation at all. So if you have an object, so this is an object PQ, and if you take another ray coming, so this is another ray coming from the end Q. It will be refracted towards the normal. Suffering total internal reflection, and then it will again move out parallelly. Now this light is coming. This light is coming from Q, so this should be the image of Q, Q dash. and this light is coming from P. So this should be the image of P, P dash. So you see, now the object and the image has reversed. It has reversed. So this is used in slide projectors to invert images. It is used in slide projectors to invert images, and this prism is always called erecting prism. This is called erecting prism. Why? Because see, it is erecting the inverted image straight. So this prism is called erecting prism. Deviation of a ray through an angle less than 60 degree. Now suppose we have, this is done by 30 degree, 90 degree and 60 degree prism. Suppose we have a prism this is 90 degree, this is 60 degree and this is 30 degree. A ray of light comes making an angle of 90 degree to the first surface. Since this is 90 degree, this angle will be 30 degree. Now, is this my angle of incidence? This is not my angle of incidence. Here we have to draw the normal. My angle of incidence is 90 minus 6, 30, 60 degree. Now since it is greater than critical angle is 42, light will suffer total internal reflection. This angle is 60 degree. If this is 60, this full angle is 180 degree. So this should be 30 and this angle should be 120 degree. Because sum of three angles of a triangle is 180 degree. If we can draw a normal over here, normal makes an angle of 90 degree. This full angle is 120 degree. Therefore, this angle is how much? 30 degree. 120 degree. 120 degree minus 90 degree is 30 degree. Now 30 degree is less than critical angle. So if angle is less than critical angle, light will suffer refraction. Now it is going from a denser to rarer medium. So light bends away from the normal. Now if the prism wouldn't have been there, light would have gone in this direction. due to the presence of the prism. Light goes in this way. So light suffers this angle of deviation. This is my angle of deviation. Now if I take this angle as x, then we can say, in this triangle we can say 120 degree, 60 plus 60, 120, plus delta plus x is 180 degree. Therefore, deviation becomes 60 degree minus x. So, deviation is less than 60 degree. Deviation is less than 60 degree. Now let us take some more examples and apply. Let us take an example of a prism say this angle is 90 degree, this angle is 60 degree, this angle is 30 degree, and a ray of light is falling at 90 degree to this surface. Now if it falls at 90 degree, it will enter straight. Now this angle is 60 degree. Now if we draw the normal at this point, here the angle of incidence is 30 degree. 30 degree is less than critical angle. So if it is less than critical angle, what will we see? Refraction. Light bends away from the normal. So light will be refracted. Let us take another example. We have a glass piece right angled at this point. A ray of light is entering normally. Say it is entering normally. So if it is entering normally, it will go straight. That means this is the center. It is coming normally to the surface. It is falling normally. Let this angle be 42. Here if we draw the normal, this total angle is 90 degree. Angle of incidence is then 90 minus 42, 48. Now because of 48 is greater than 42, more than the critical angle, light will suffer total internal reflection. If the angle of incidence is more than critical angle, it will reflect. This angle is 48. Therefore, this angle is 42. 42, 90. This should be 48. Sum of three angles should be 180 degree. Here again, we draw the normal. This is 90 degree. So this angle should be 90 minus 48, 42, 90 degree minus 48, is 42. Now 42 is the critical angle. 42 is the critical angle for glass. So what happens? Light will graze out from the surface. Since this is the critical angle, here light will graze out from the surface. Angle of refraction is 90 degree. So this piece is made of glass. This is glass whose critical angle is 42. Light falls normally at an angle of incidence 48. First suffers TIR because here the angle of incidence is more than the critical angle. IC is 42. Here angle of incidence is 48. So it is greater than critical angle. So what happens here? Total internal reflection takes place. Here if this is 48, this is 42 because full angle is 180 degree. This is 42, 90, this is 48. Sum of three angles is 180 degree. Draw the normal. This is 90. 90 minus 48 is 42. 42 is my critical angle. And when light falls at a critical angle, it will graze the surface, making an angle of refraction 90 degree.